Okay, so let's see, you got 5 times 57.
One more decimal place than was it?
318. 440. 24. 385. Is that right? So if you add them all up, you get, then sheet 1637.
Yeah. Yes.
And then you're going to divide that by total number of days you have.
Miss Young,
Yes.
I think the last one is 285, right?
Oh, I'm sorry. You're right. It is 285.
Oh.
And then what did you guys get for your answer?
Right. 54.6.
54.6. Great. Thank you. Yeah. All right. Good. How many decimal places should I have? One more than my original data is in. Right? Okay. So one thing to think about is, because people don't know, they always get confused about what to divide by. Remember, this is just an easy way of adding things up. You really have 30 items you're adding up. You're shortcutting the adding. That's all you're doing. It's still all 30 of these that you're still adding 4 of those, 6 of those, 3 of those, 8 of those, right? You're still adding up 30 numbers. We just shortcutted it by doing some multiplication instead. There's still 30 days. Okay, good. So find the weighted mean of a variable. How do you do it? Multiply every value by its weight, which is what you guys did. Right? You had 4, 50, whatever they were, the first numbers, right? So you multiply every number by its frequency or by its weight. The thing is, weights don't have to be whole numbers. They can be decimals also. You can have a third of this. You can have a tenth of that. You can have 20% of this. So you multiply every number by its weight, add them up, and then divide by the sum of the weights. What you guys did with the sum of the frequencies. I think on your sheet you have some things to define. So we have X bar. That is, what's X bar? Yep, it's your sample mean. What's X? So X are all your individual data values. So X is your individual data values. You guys are filling out the sheet on your right, on your sheet, right? In your notes?
Yes.
What's your, is it the sum of the W's next, or is it the W's? W? W are the weights, the individual weights. All right, so like in our example, 52 had a weight of 4. Everybody with me? All right, so the value of 52, the X of 52 had a weight of 4. And then the sum of the weights, well, that's the sum of the weights. You add them all up. So the weights are kind of things that don't change. They're sort of, they're not, let me rephrase that. The X's are your variables. So the things that vary, like in this case, what varies during the course of the month? The temperature of the water. So the temperatures are the things that vary. So those guys, those are the ones, those are your X's. Those are not the things you're dividing by. You're not dividing by those. You're dividing by the other things. The other things are the weights. And we'll see another example of that in a little bit. Like right now. Okay, so who's ever computed GPA before? Okay, a couple people. The rest of you will do one right now. So how this works, a GPA is, I have English composition. You get an A in it, but it's not worth as much as biology. because biology is 4 units. So 4 units has a stronger weight than a 3-unit class or a 2-unit class. Everybody understanding that? This class is a 4-unit class. It will have more weight than a 3-unit class you guys are taking. So if you take this class and you get a B, take that class and you get an A, they don't average to a kind of a 3.5. This one's it's weighted a little bit stronger. So this is the one you want to get an A in because it's higher, it's weighted more. Okay, so the way you can kind of think of it is sort of like this. If I have an A and it's worth 3 units, it's really like kind of having 3 little A's, each worth 1 unit. An A is worth how many points? 4. You guys are comfortable with the idea that A's are worth 4 points, B's are worth 3 points, C's are worth 2 points, and stuff like that? Okay, so that seems good. So really this is like 3 little 4s. And this C is like 3 little 2s. The B, and then the 4 B's is like 4 little B's. And this is like having 2 little D's. And so this is really what this means. And then you're just averaging those numbers there. But again, the easy way of doing that is to say, okay, I have 3 A's, 3 times 4. It's just an easy way of adding them up, right? And then you're going to divide by what? How many there are. How many there are there? Yeah. It's all about the credits, how many units they have. So why don't you guys work on this problem, finish this problem, and then we'll take a look at it. Okay, if you add up all those, you end up with 32. And you divide by what? 12. I'm going to move this over. 32, and you divide by 12. So here's the thing. How do I know what to divide by? The sum of something, but, so think about it like this. What varies in this problem? Yeah, how many units a class is, or what people's grades are? The grades. Because for all of you guys, how many units is this class? 4. It's not 4 for some of you and 3 for others of you. What's going to vary for all you guys is what grade you guys get, right? So that's our variable. You do never divide by the variable. You divide by the other thing. Good? So here we're going to add up these guys. That adds up to 12. We're going to divide by 12. Another way of looking at it is this. This is, how do we get to 32? We multiply credits times grades. Everybody on board with that part? Yes? So this is credits. This came from credits times grades. Okay, what do I want? Do I want the average credits, or do I want the average grade? What am I looking for? The average credit or the average grade? Average grade, which means that I need to get rid of the credits. So it means I need to divide by credits so that I'm left with grades. Do you see what I'm saying? Because credit over credit is 1. They cancel out. So I need to divide by credits. How many credits are there? 12. So divide by 12 credits. Then these guys cancel out and go away. And I'm left with grades. So then I have my average grade. All right, so what do you guys end up with? 2 point, look at your rounding. 2.7. Or 2.67 if you did be rounded to 2 decimal places. So it should be 1 decimal place. In real life, people usually do GPAs into 2 decimal places because they need a little more delineation between students. So if you did 2, that's fine because that's what the world does. And if you did 1, that's fine because that's what the official rules are. So either one of those is full credit on the exam. They did 1. All right, so group data is a little bit different. So here is an example of group data. All right. Okay, guys. So I have right, Lindsay, thanks for volunteering. Go ahead and explain what's going on here.
Do you want me to read it or?
Yeah, what do you think? What do you think is happening?
There's a different like IQ scores between like a sample of people.
Right. So different IQ possibilities, right, with this table. Now, how many people have an IQ between 50 and 69? 2 people. So what should I use for those 2 people for a number? Should I use 50? Should I use 69? What should I use? Why the midpoint?
That's how you grab it.
That's the middle. So here's the thing. If I pick 50, how big of a mistake might I have made? Yeah, 19. They might be at 69. Do you guys see what I'm saying? If I pick 69, how big of a mistake might I have made? They might be where? That might be as low as 50, so I might have made a really big mistake there. So here's the problem. I've got from 50 to 69. If I pick a spot over here, they might be over here. If I pick a spot over here, then they might be over here. So the reason why, whoops. So the reason why we pick the midpoint is because it kind of cuts your error down, right? The furthest away, this is kind of the most representative number for that class. It could be here, it could be there, but it's not like you're picking over here and it could be way over there. It's kind of the average for that class. Does that kind of make sense? So we're going to use the midpoints. So here are the midpoints for each of the classes: 59.5, 79.5, 99.5, 119.5, and 139.5. How many 59.5s do I have? 2 of them. So I can multiply it by 2. How many 79.5s do I have? 33. I can either add 79.5 33 times in my calculator, which is a big pain in the butt, or I can just do 33 times 79.5 and add them all at once, just like that, really easily. So again, remember, this is just a shortcut for adding all of these up one at a time. I still need to divide by how many there are. How many of them are there? 78. 78, my frequency. Good? And again, you pick the thing that doesn't vary. What varies amongst people? The IQs. So you're not dividing by the IQs, that's your variable. Divide by the other thing. Your frequency or your weight. All right, so you guys are going to have a problem now where, so here are the steps. Make a table, find your midpoint, and then your frequency times the midpoint. Find your midpoints. Multiply each of your frequencies by the midpoint of the class. Put that in column D. And then add all those up and divide it by the sum of the frequencies. Okay, so you guys go ahead and do that with your, I'm sorry. Stop me when I do that. You folks, right, gender neutral, just I'm out of practice here. You folks are going to do that with your problem, which is,
Here we go again.
what? This one. There we go.
What was
All right.
in column D? What was the formula?
Oh, do you guys want the formula? I can give you the formula.
So we have to find it.
Is that the one you want?
Yeah, for the D,
Or you mean,
or the column D formula. Oh, after.
okay, so that helps you. Okay, check your answers. Everybody got that? Those answers correctly?
Wait.
All right, so let's take a look. What's the properties? Alberto, go ahead and read for us.
Properties of the mean found by using all of the values of data varies less than the mean or mode used in computing other statistics such as the variance. Usually not one of the data values cannot be used with open-ended classes affected by extremely high or low values called outliers.
Great, thank you. Alina, go ahead and read for me.
The median gives the midpoint used when it is necessary to find out whether the data values fall into the upper half or lower half of the distribution. Can be used for an open-ended distribution affected less than the mean by extremely high or extremely low values.
Right, so that's the nice thing about the median. Right, the median, so if the median home price is $1 million, then it doesn't matter whether the highest home price is 5 million or 100 million. It's not going to change the median. So that's kind of the nice thing. It's not affected by those outliers. Properties of the mode. Juan, go ahead and read for me.
Use of the most typical case is desired. Easiest average to compute can be used with nominal data, not always unique or may not exist.
Yep. Yeah, that's the nice thing is that with the mode, you can find, if you're looking at hair color, you can find which hair color occurs the most, but you can't find the average of hair colors. That doesn't make any sense, right? Properties of the mid-range, it's easy to compute. However, the mid-range is affected by extremely high or low values. So for example, I've got 49 people who make $25,000. I've got one guy in the company who makes $1 million. What's my mid-range? $1 million, 25,000. Find the middle. What is it? Like $500,000, right? Just over $500,000. Is it fair to say that the average employee makes $500,000? No, because it's outlier. If you take the median is $25,000, right? Because 49 people make $25,000. And even the average, well, the average will get affected some, but the median is like kind of really good when you have those outliers like that. Let's take a break. It is 5 after now, so we'll come back at 10 after, like by the real clock. 15 after, by the real clock. Yeah.
Each and every day, media fills our heads with numbers. The economy, crime rates, test scores, poll results, and medical studies. It's nearly impossible to get through the day without hearing numbers in the news. When it's not numbers that we're hearing, it's often the results of statistical studies that newscasters and TV show hosts are discussing. Some of the headlines are so poorly thought out that they're funny, while others, those are scary. H.G. Wells once said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Well, boys and girls, one day is here. The hardest part of statistics is collecting data. Poorly collected data can produce misleading results. Consider the publishing company that is trying to get an idea for a new magazine that will appeal to a certain community. Using their knowledge of elementary statistics, they come up with a simple random sample of residences in that area and call the homes during regular business hours, asking about their favorite magazine. The results? Overwhelmingly, the majority of respondents answered Parenting Magazine or House and Garden. The problem? They called during business hours when most people are at work. Stay-at-home moms are most likely to answer the phone during these hours. This sample is not representative of the population of interest, and the results are therefore inconclusive. The publishing company has wasted valuable time and money. Even when appropriate sampling techniques are employed, the questions posed need to be carefully worded not to elicit biased responses. A sample of people were posed the question. Researchers at a leading university claim that electromagnetic fields produced by devices like cell phones may cause cancer and other neurological diseases. Do you agree? The vast majority of people in this sample responded with yes. Do you think that the results might differ if the researchers had simply asked, do you think cell phones cause cancer? Certainly. If a leading researcher says it's true, people are likely to agree with that result. Most of us certainly don't know enough about electromagnetic fields to draw a conclusion on our own. Who's going to disagree with professors at a leading university anyway? If that's not convincing enough, allow me to lend an example from my own life. When I was in 4th grade, if someone would have asked me, "Do you believe in Santa?" I would have answered, "Yes." But when my mom casually asked, "Emily, you don't still believe in Santa, do you?" Not only did she basically tell me Santa wasn't real, I felt as though I had to answer no. Sometimes bad statistics are produced by the numbers themselves, rather than the collection methods. Careful exploratory data analysis must be done in order to choose appropriate ways to report summarized data. Consider the following true statistic. The average starting salary of geography majors graduating from the University of North Carolina in 1986 was $250,000. Why are UNC geography grads making so much money when nationally graduates in geography are starting at $22,000 a year? Michael Jordan earned his geography degree this year and went on to make over $700,000 in the NBA. You see, the average is computed by taking the sum of the data values and dividing that sum by the number of data values. This measure of center is highly affected by outliers, an individual value that falls outside of the overall pattern of the data. While the average is accurately reported, the statisticians should have used the median or the middle value to report the average starting salary based on the presence of extreme values. Technically, the information gathered in these examples are accurate. They're just misleading to someone who reads the reports and is unaware of the methods used for gathering or analyzing data. Be a skeptic and be educated so that you aren't a victim of bad statistics.
So, that again is just emphasizing a few different points that I talked about. It touched on a few different things. One of them being that whole concept how that mean is totally affected by outliers, right? So like 3 people are making $22,000, and then Michael Jordan's making 700 and something, and he just pulls the mean over that way. Okay. Another thing that we touched on once before, but I wanted to bring up again, was talking about the different distributions, right? So you have a normal distribution. The normal distribution, the mean, median, mode are all smack dab in the center. And then I think there was someone in this class who talked about how their instructor talked about left skewed and right skewed. So like right skewed means that you skew to the right, right? So this is right skiing, right? And then this one, you skew to the left, right? So, and you'll notice in the right skewed, the mean is pulled off to the right. In the left skewed, the mean is off to the left of the median. So that's kind of how those work. All right, now we're on to 3.2, measure the variation. Range, why am I reading? Michaela, read for me.
R equals highest minus lowest.
Right. The range is the highest value minus the lowest value. Remember, we used the range earlier when we were looking in chapter 2 at how people talk about class widths. Why does range matter? Lauren, go ahead and read for me.
Why does range matter? Say you are buying a television and have narrowed your choice down to 2 models. Looking at reviews, they're similar except for the amount of time each lasts before breaking. The table to the right shows the number of months each lasted for its reviewer before breaking. Find the mean and range of each model.
All right, so say this one is LG. These are like 6 people who reviewed an LG TV. And then model B, say that's Vizio. Right, so 6 people who bought a Vizio TV and reported on it. So this, and then in their reviews, They talked about, oh, it lasted this many months before it broke. So this is a sample of people who bought the LG TV. This is a sample of people who bought the Vizio TV. Good? Everybody on board with this part so far?
Yeah.
You need to find the mean and the range of the LG TV and also of the Vizio TV. Good? They're two separate ones. It's two separate groups. The LG group, the Vizio group, two different groups. Find the mean and range of the first group, find the mean and range of the second group. You're at home, pause your video and do it, then resume when you're done.